There's 104 days to your examination and you haven't read shit. But don't worry, I'm gonna get you that A that you need to pass. Like maybe algebra with sports. Ronaldo is the GOAT, man. So this is my first video. It's kind of weird, but I'm gonna take you guys to delete that algebra fear. Algebra is easy, guys, but I can make it fun. Let's go. So in this video, I will be talking about the basics. You can probably skip it if you feel you're comfortable with numbers, but don't because it's still funny. So we're looking at the prerequisites. So just basically numbers. So we know math is about numbers. So the basic is zero, nothing. Then we have 1, 2, 3, 4, 5. 6, 7, 8, 9, 10, and you have 10. For example, we have 10 fingers, which we use to shoot, which you use to shoot that basketball of yours. Ah! Which you use to shoot that basketball of yours. But of course, you suck. You suck. Ah! Next, we also have 10 toes, which my goatee Lewandowski used to shoot the ball. Man, I love Barcelona. I hate Real Madrid. Now, normally we can go above 10 and 20, of course, because we have this magnificent machine in our heads called the brain. But because we've been scrolling and we've basically lost our intelligence, our brain has become this instead. How tragic. So, thankfully, we have these other machines, unless, of course, you're young Sheldon or that Asian kid that we all know that is going to be better than us. What is the hell is wrong with Asians? Like, they just built different. Like they were built for this shit. Okay, so those are the numbers. Next, we have negative numbers. Negative numbers are a bit weird in the fact that, of course, in the game, for example, you can't have -2 points. That's kind of stupid. But I like to think of negative numbers as an alternate reality, an alternate world. For example, in the normal world where we have the normal numbers, Arsenal hasn't won a Champions League. And they probably never will because there's no way they're going to be Barcelona on the right side of that competition, yo. Let's admit it. Try again next year, Arsenal. Then we have the negative numbers. Now think of this as, you know, a world where Arsenal is like Real Madrid, they have like 15. So those are negative numbers. And these positive and negative numbers, basically alternate realities, are connected through this line, the line of fate. It's just called the number line. I'm just exaggerating. So this number line basically connects them, and basically the sum of all the positive, which are normal numbers 1, 2, 3, and negative numbers all together are called integer. So when you hear the word integer, it's basically telling you it could be a positive number or it could be a negative number. Easy peasy, right? Now, next, let's go to rational numbers. Rational numbers is just a flashy way of mathematicians trying to say fractions, Like, it's really not that hard. Rational numbers are just fractions. So basically, when we take two integers and we divide them by each other, we have a rational number. So for example, let's say Ronaldo is an integer and Messi is another integer, and those are two separate people. And then look at what happens when I use AI and divide them. We have this. So of course, rational numbers are a bit weird too, but they're just basically trying to divide two integers. Remember that, guys. So your examples: 15/8, 4/10, 3/5. This Of course, fractions can also be turned into decimals, with that calculator of yours. So some of these fractions are terminating. So they end in the decimal point, they end. So for example, 15 over 8 is simply one in decimal form is 1.875. 3 over 5 is just 0.6. So they end at a point. Some of these rational numbers are a bit more crazy. For example, 3 over 10 just keeps on, going 0.33. Because we can't write all the threes, so we just put the dot dot dot. And 4 over 11, which is just basically 0.36363636, and it keeps on repeating. They're a bit more crazy, but they're still rational numbers, I guess. Then the weird thing is that all integers basically can be turned into rational numbers. How, you might ask me? Remember, rational numbers, like I said, are just fractions. So basically, if we divide any integer by 1, we have turned it into a fraction. So, that's just like a hack, I guess. Next, the final classification of numbers are called the irrational numbers. These are your numbers that have no sense. Like they are crazy, like Real Madrid fans. Blah. So irrational numbers are basically numbers, or they are basically fraction decimal numbers that can be written as fractions. So unlike rational numbers that can be written as fraction, when you can write a number as fraction only as a decimal or another weird form, it's called an irrational number. A good example, any square root number that doesn't have square roots like 2, 11, you know, are all irrational numbers. And then when you see a number like this, for example, so the number doesn't really follow a pattern, and there's no way we can convert this number to a fraction, so reasonable fraction at least. So it's an irrational number. Okay, just a brief recap. All these are called real numbers. So basically, the table should look something like this. We have real numbers is just every single number in the damn world. Then of course we have integers, and then we have rational, and we have irrational. Integers are just whole numbers that can either be positive or negative. Rational numbers are just fractions, and then irrational numbers are decimals, but we can't write them as fractions. That's easy, guys. That's all it is. So now we all know the weird kind of numbers. Let's go down to some special stuff. Not really special stuff, just basic stuff. So we all know the basics of math and football too. We have addition, which is like passing like KDB. We have subtraction, which is like Ramos targeting your legs and giving you that terrible ACL that's gonna end your whole career. I look hates this guy. We have multiplication, which is shooting from outside 40 yards and scoring a banger. My goat here does it all the time. Give him some respect, man. We have division, which is breaking those players' leg with those skillful feats. Nay nay. And then we have square root and square, or basically exponents. We'll look at this at a later time, but let's just, you know, use exponents, which is like Couture. Bro is just on fire, bro. Like, bro should retire already. If bro retire, Real Madrid is not going to win another UCL for 15 years. Trust me. So all these are operations in math. So basically, we use them to combine numbers. And when we're using multiple, like when we're using a multiple of these operations, we need to follow a rule. known as PIMDAS. Is it me or does that somehow sound like pedo? Just saying, just saying. So PIMDAS basically follows the rule which says P stands for parentheses, E stands for exponents, M stands for multiplication, D stands for division. A is addition, S is subtraction. So basically, the lines I put is just, you know, where the ones you might have to do first. So you have to solve anything in the parentheses first, then deal with the exponents, then multiplication and division. It doesn't matter which one you actually start first, but multiplication, division, and addition and subtraction, same thing too. So let's use an example actually. I have this good example. So we're gonna start with the exponents. So the exponents usually refer to square or square root. So you're gonna solve what's in the square root and anything related to the square. So 5 squared we know is 25. So 25 minus 4 all over minus 7 minus 11 minus 2 is a 9. So this is 25 minus 4 is a 21. All because basically this is, you could actually say that it's in its own area. So 21 divided by 7 minus square root of 9 is a 3. So we're done with the exponents. Now, like I said, we're going to follow the division before we subtract. So that's 3 minus 3, and we have a 0. All that for a 0, man. How disappointing. So basically, you're probably used to it. These are just the operation that they have to follow. If I do one before the other, it could result to it being a wrong answer, and that's why you have to kind of follow it. So why don't you try this on your own? Now, let's look at properties of real numbers, that's numbers of a whole. Now, usually when we talk about properties, for example, when you see Real Madrid, you think of UCL, because they won 15, which is ass. When you think of Barcelona, you think of Tiki Taka. Prime Barcelona was unstoppable, man. When you think of this man, you think of shooting 3 pointers and putting niggas to sleep. When you think of Usain Bolt, you think of speed. When you think of this guy, you think of money and Tesla. Basically, the reason why we're going to be dominated by Ultron in the next few years. Yeah. And then when you think of this, you feel so relieved because you know that Alfredo Di Stefano, will help you pass your exams. No need to fear, because we learn science with sports. Mwahaha! Anyway, so basically, the numbers have the same characteristics. Sorry, they have their own characteristics. So, which is a 1, doesn't matter if it's a 1, a 20, or 11, whatever it is rather, is gonna have, all numbers have characteristics. So let's look at some of them. Um, this is called a commutative characteristics of numbers, and it only works for addition and multiplication. Take note of this. You probably already know all these characteristics, but let's just point them out. Basically, commutative, but basically saying that 7 plus 11 is the same as 11 plus 7. So it doesn't matter how you place it, it's always going to be the same. For multiplication, to 7 times 11, which is 7, is the same as 7, which is the same as 11 times 7. It's going to give the same thing. It doesn't work for minus and division though, because 7 minus 11 is minus 4, because and 11 minus 7 is 4. So that's kind of, they aren't the same. We are not the same. 7 over 11 2 is not the same as 11 over 7. So this property only works for addition and multiplication. Associative is another kind of communi- communicative, basically, where it was saying for addition and multiplication again, it doesn't matter how you group it, it's going to give you the same answer. For example, 3 times 4 times 5 is the same as if I decide to do 5 times 3 first and then decide to times the 4 later. 3 plus 4, if I keep it in a bracket and I later add the 5, is the same as, if I decide to do 3 plus 5 first. So again, it only works for addition and multiplication. Distributive is another characteristics which again involves multiplication and addition. Why are we leaving subtraction and division out? Kind of sad, man. So in division, basically, sorry, in distributive, what we're basically saying is when, of course, we can solve this by, if we follow the PIMDAS and we deal with what's in the parentheses first and then add it by 2. Another approach is that when we can actually multiply the 2, can actually multiply the 2 by the 3 and also multiply it by the 5, and we'll still have the same answer. So this becomes 2.3 plus 2.5. This becomes 6 plus 10, and you still have 16. The same thing if we had just done PIMDAS, we'll get the answer. The reason why we're looking at these characteristics is because when we start delving into, using letters, so it won't be weird. Okay, so we still have the same answer. So when multiplication and addition are mixed like this, we can actually distribute it by multiplying each number against the other while keeping the addition sign. Another, also in distributive, subtraction doesn't work too. But so again, subtraction is being left out. But the reason why we can still distribute with a minus sign is because of this. We can always include an imaginary positive sign. So looking at this, we have 4 brackets, open brackets, 12 minus 7, close brackets. Now, usually you won't actually be able to just say 4 times 12 and 4 times minus 7 because it doesn't work like that. But because of the fact that we can edit 12 minus 7 to look like 12 plus minus 7. So that is the thing with distributive. It only works with multiplication and addition. But because of the fact that we can arrange, 12 minus 7 to look like 12 plus minus 7, because it's still going to be the same thing. So when I multiply this, I have 4 times 12, which is 48, plus 4 times minus 7, which is minus 28, and I get the same answer, which is 20. Now, of course, that doesn't mean that when you want to expand, you have to keep on, trying to add the plus. Because of this, I'm just trying to show you the rule. Because of this, next time you don't have to, you can just go along with the flow. But just know that distribution only works. So next time, because of course, that the plus is already there, you can just go ahead and do 48 minus 28, which is 20. The same thing again. Distributive property only works for addition and multiplication. So when there's a minus, it doesn't work. But because of the fact that we can always add a plus in front of the multiplication. For example, this example, 12 minus 5 plus 3. So we can add that plus and we know minus is basically a -1. So this becomes 12, and then the -1 can now distribute. So this becomes plus -5 plus -3. Again, we don't have to, because of this rule is already established. Next time, we can just distribute the minus itself. So this, you can simply just write 12 minus 5 minus 3. But I'm just showing you the rule again. So try some examples on your own and make sure you can distribute really fast. Identity is another characteristic, and is quite is another one where we're basically leaving out subtraction and division. What is this discrimination? So for addition, we're basically saying that when you add 0 to any number, the number stays the same. So it doesn't matter whether it's a 7 or -6 or square root of 11. Adding 0 to a number doesn't change it, so the number stays the same. For multiplication, the identity characteristics, we're basically saying that uh, when we multiply a number by 1, it stays the same. So 7 times 1, still 7. -6 times 1, still -6. So it doesn't matter what the number is. So for addition is a plus. Adding a 0 doesn't change anything. For multiplication, adding multiplying a 1 by it doesn't change anything too. And then inverse characteristics, which is our last characteristic, basically saying that adding, when it comes to addition and multiplication, again, basically saying that a, for example, if we have a number, let's call it 7, and we add its additive inverse, which is like, for example, remember, negative numbers like another universe. So if in this universe I'm a 7, then in my other universe I'm probably a -7. So when I add these two numbers together, I have a 0. So that's basically what that rule is saying. Same thing for multiplication. When we divide a number by itself, we have 1. So they're pretty obvious, pretty obvious rules. I'm just clearly stating them out. I'm so sorry, subtraction and division, I don't know why multiplication and addition are always leaving you out. I can relate a bit. I have no friends, and that's why I'm doing this, so that you guys can pass and be with your friends rather than going to summer school. Say no to summer school. So this is where we'll be done with numbers. Join the next video and let's start doing variables. That's where the real business is. Thank you for watching. Like and subscribe. This is my first video, so I really appreciate all the love. Tell me in the comments what you don't like. This is my first video, so it's pretty kind of, it's just kind of there. So I know it's not going to be perfect, but tell me what you like. Tell me what fan are you. And like I said, hate to all the Real Madrid fans. You guys are losing to Bayern next week.